So we're trying to talk about this, all right? So these are the various independent non-parametric tests you can do, all right? So recursion, rank, sum, or Mann-Whitney U test, all right? So it's either you call it Mann-Whitney or WILCOXON rank sum test. I think it's a combined work that they did, so any of them qualifies to be given the credit. All right, you can also do median test. You use sign information for test differences between two or more independent random samples. All right, Fisher's exact probability test, so that is a special version when you are trying to do a 2 by 2 contingency table. We have Kolmogorov-Simorov test or Kolmogorov-Simorov test, all right, for comparing two populations and testing for goodness of fit. So here too you test for goodness of fit, but I think this is quite for quantitative data, all right, or continuous data. So, and then the ANOVA counterpart in non-parametric is Willis and then Freedman's test, all right. So we'll be discussing almost everything there, all right. So let's start with the recursion sum rank or Mann-Whitney U test, all right. Remember that in this we always need the distribution table, right? So if I don't make available the distribution table, probably I would make it available on the next video. So try to subscribe to the channel so that when the next video comes you will see, and then you go and see the table and then try to work something out, all right. So the test is practically designed to compare two populations based on independent random samples. Okay, so if you've not done a lot of statistics, let's try and look at samples that are independent, all right. So when we are talking about independent samples, some people say unpaired. It's actually when you try to take data from two different populations. Okay, so yeah, even if no population, let's say two different samples. So this is another sample. This is also some sample from a certain population, right? Sample from a certain population. The way you took this sample had nothing to do with the way you took this sample. So we say that these samples are independent, all right. So how somebody got into this sample has nothing to do with how somebody got to be part of this sample, all right. So we see that the samples are independent, right? Okay, so you want to try to check whether the distribution for this, all right, is the same as the distribution of that, all right. That is the main thing you want to do. You want to check the distribution, okay, and see that is the distribution of this data or this sample the same as this, all right. Remember that this sample represents some population and this sample represents some population, all right. So you want to see that, all right, this might have some distribution, this also might have its own distribution, but are the distribution similar or the same, all right. Are they the same at a certain level of significance? Can we be sure at some level of significance that yeah, these two samples, when you infer in their populations, you can say that their distributions are the same? Can you do that? All right, so you want to test that to using the Mann-Whitney or recursion rank sum test, all right. So this is the procedure. Remember there's a rank, so the most important thing that we'll be doing here is to rank. Rank means you arrange them in a certain order from the lowest to the highest. Okay, so the procedure says that given two independent samples, random sample sizes n1 n2, drawn from the two populations, what we do is that we try to sum them up and rank. So add everybody together just assume that they are from the same population, put them together and try to arrange them. So assuming that you went to a school, some private school, you took sample from there. You went to some government school, you took sample from there. All right, so you have two independent sample, right? So for you to do this test, what we do is that put all of them in one class, right? Put the private student and the government student, the sample you pick, put all of them in one class. So when you put all of them in one class and try to rank them, number them, right, based on the magnitude, the values associated with them, right, the values associated with them, rank them based on that magnitude. All right, so assuming it's marks, you took the marks of some private school, you took the marks of some government school. What you're trying to do is that combine these guys, put them into one class, their marks, and try to arrange the marks in order, okay, from the highest to the lowest. That's the first thing you have to do when you're trying to do recursion rank sum test. So when you do that, when there is a tie, okay, take note, when there's assigning 1 to the smallest value, observation 2 to the second, and so on. Ties in observation are assigned the mean. All right, so if there is a tie, then you try to find the mean rank, right, and give it to them. So assuming that as you are ranking, you saw maybe 40, right, 40, and then let's say 40. So these are the marks of some 3 students, and then I think this is supposed to have been the, let's say, the number 4, the rank, but this is also going to be 4, this is also going to be 4, right? So in that case, you can't just say 4, right? So find the mean. There are how many? 1, 2, 3. So what you do is that you do 4 plus 4, all right, plus 4, all right, and then there are how many? 3. So divide by 3, okay. So when you divide by 3, all right, and then you give it to them, okay. So we'll actually look at some typical example, and then we'll see, okay. So let's see. Let's see, probably it might look something like that, or maybe something different. So we'll check that. No, I think it shouldn't have been that. The right thing is this would have been 5th, and this would have been 6th, okay. So I think you have to sum 4 plus 5 plus 6 and divide by 3, right? So that's what I was just looking at, this 4 plus 5 plus 6, all right, and divide by 3, and then whatever you get, you give it to all of them, all right. So if you get 4.5, you give it to 4.5, 4.5, 4.5 in that order, okay. Right, so that's how it is done. So if there are 3 observations and this is supposed to have been the 6th, then this would have been the 7th, and this would have been the 8th. So sum them, divide by 3, and give it to each of them, all right, as their rank, and then make sure that the next rank will just continue from this. So if this was supposed to have been an 8, you won't count the next rank. If maybe there is a 41, the next rank will not be a 41, it will not be 8, it will just move to a 9, okay. All right, even though this would have been maybe 7.5, 7.5, 7.5, but this will straight away move to a 9, okay. So take note of that. Right, so when you are done, okay, you are now going to compute the rank sums. That's why we say rank sum, recursion rank sum test, recursion rank sum test. So now when we are done, right? So what we did is that there are two populations with some marks. We combine them, put them in one class, and then arrange them in order from first to last. So when we are done, then everybody with its position will go back to its respective classes. So the private schools with their positions will go, and then the government schools with their positions will go into their class. All right. So in here, remember we have ranked everybody. So we'll sum and find their rank sum. Okay, and we call that R1. Okay, and then in here to find their rank sum and call it R2. Okay, all right. So now when we do that, what we use that to determine is to determine our U statistic. Okay, our U statistic. So how to get our U statistic? Now that we have our rank sums, then to get our U statistic, we will need our rank sum and our sample sizes. So we need our U statistic, and the U statistic is calculated from the minimum of U1 and U2. And how do you get U1 and U2? We said U1 is giving us N1, N2, and then half N1 plus 1. And then the other part is minus R1. Okay? The rank sum for the data for the private school. And then when you come to U2, alright, I think it's a mistake. This is supposed to have been a U2. When you come to U2, you have N1, N2 plus 1 over 2 N2. So you see what changes the N2 here, and then you have N1 plus 1 minus N2. So what you can do is to look at this. If you are doing U2, there is N2 here. Alright. If you are doing U1, there is N1 here. Alright. And then there is R minus R2 for U2. Alright. And then there is R1 for U1. Okay, take note the formula. Right, there is another identity which can also be used. The fact that you found U1, alright, then you can use this formula. Now you know U1, so you can say U2 is just equal to N1 N2, alright, minus U1. Alright, so this can be done. So that you get is your test statistic. Okay, it's your test statistic. So then you would go ahead and then use that to do the work. All right, so we'll try to look at it when the sample sizes are small or when the sample sizes are large. Okay, so when n is large, U1 will be smaller, and then blah blah blah. So I think there is small sample and then a large sample. Okay, so when the sample sizes are smaller, what we do is that we'll use the distribution table. Okay, so when the sample size are smaller, we'll use the distribution table. Otherwise, we'll go ahead and use the z table. Okay, so in this course, it happens that when the sample size are smaller, we'll use the distributions table associated with that test. So here we're going to be using the Mann-Whitney or Kruskal-Wallis distribution table, Mann-Whitney or WILCOXON rank sum distribution table. All right, so remember that you're going to be looking for this probability that that's U0 you found. Remember, U0 will be the minimum of U1 and U2. Right, U0 you found is kind of that probability you look, is it less than or equal to half over 2 for a two-tail test, all right, and then for a one-tail test you will just compare with alpha, right? So remember, these are we are testing the distributions, so take note. So all the time the state the hypothesis is very important. So the two distributions have identical probability distribution, so you can say probably the two distributions are the same against the two distributions are different. Okay, that is if you are doing a two-tail test. So one-tail test, it could be that one of the distribution is maybe shifted to the left, or the other distribution shifted to the right of the other. That's one tail. Okay, so if it is two tail, we say the distributions are the same against the distributions are different. But if it is one tail, you say that distributions are the same against the distribution, one is probably shifted to the right of the other, or the other is shifted to the left of the other. All right, so take note. And then in small samples too, you take note that n1 and then n2 should also all of them be less or equal to 10. Okay, so in the next video we'll take a typical example involving a small sample, then we'll consider the large sample too as well. All right.